Hey kids, we're going to finish up our One Well book today. We left off yesterday talking about people in water and all the different ways that we use it. We're going to continue today with fresh water in the well. Though we live on a watery planet, not all of that water can be used to meet our needs. That's because we humans and many other species depend on fresh water, and supplies of fresh water are limited. Most of the water on Earth is saltwater, almost 97%. Only 3% is fresh water. If a tanker truck filled with water represented all the water on Earth, then the water used to fill a large bathtub would represent all the planet's fresh water. Most of the fresh water, over 99%, is frozen in the polar ice caps and glaciers, trapped deep underground or in the atmosphere, or we can't use it. How much fresh water is available to us? Remember that bathtub? Imagine filling 9 pop cans from it. We know those are soda cans, right? This represents all the fresh water we can use. While there is a lot of water on the planet, we have access to less than 1% of it. So this is why it's so important to take care of our water and make sure we're not polluting it. There's some interesting pictures along with some captions. Lake Baikal in southeast Siberia contains almost 1/5 of all the fresh water on Earth. It's also home to the Baikal seal, one of the world's few freshwater seals. You can see it in the picture there. Approximately 0.001% of all water on Earth is in the atmosphere. If a tanker truck represents all the water on Earth, the water in the atmosphere would barely fill a third of a soda pop can. That is not very much. The Bering Glacier in Alaska is the largest glacier in North America. It's about 5 times bigger than New York City and nearly twice as tall as the Empire State Building. That is a big glacier. Around the world, more than half the drinking water we use comes from underground aquifers, layers of gravel, porous, also known as holy, rocks or soil that trap large amounts of water. And the Edwards Aquifer is very near to us. It runs out underneath West Texas. Access to the well. Some families are lucky. They can turn on the tap for drinking water to fill a bathtub, wash their car, or water the garden. But other families around the world are less fortunate. 1 billion people, almost 16% of Earth's population, have to walk more than 15 minutes to get the nearest water supply. There they gather water for the day, just a few jugs, barely enough for drinking, cooking, and cleaning. Other families don't have access to enough water to meet even those basic needs. While the amount of water on Earth is always the same, the distribution of water across the world isn't. Huge differences in rainfall can happen from country to country, and even within the same country. Less rainfall means less water available in lakes, rivers, and aquifers. Sometimes there just isn't enough water where it's needed most. Because water is not evenly distributed across the globe, nearly 1/5 of the world's population does not have access to enough water. Many of these people live in Africa and Asia. And you'll read about this in the StoryWorks lesson, 2 miles for a drink of water. A bucket of water weighs about 10 kilograms, 22 pounds. Imagine if you had to carry a bucket or 2 from a well to your house every day. That is heavy, guys. 22 pounds is heavy. North America has 1/3 the population of Africa, yet North Americans use 3 times as much water. How is this possible? Nearly 300 million people in Africa do not have access to enough fresh water. So let's look at this graph. We see that we're using a bucket. 1 bucket is equaling 10 liters or 2.6 US gallons. And we see they've got it labeled here: North America, Russia, Poland, India, Nepal, Haiti, and Ethiopia. This is the average daily water use per person. So think about that. Do you use that much water each day? And look at Ethiopia, only 1 bucket of water per person each day. China and India are home to over 1/3 of the world's population, yet they only have access to 1/10 of the world's fresh water. Demands on the well. This is a big number. What do y'all think that is? 7,324,782,000, give or take a few. That's how many people there are on Earth, and that number is growing every day. More people means a greater demand for water. But this growing population isn't the only thing putting a strain on our water supplies. The average person today uses about 6 times more water than 100 years ago. A growing population also means we need more space. As towns and cities grow to accommodate all these people, they gobble up land, which also affects nearby water. Houses, buildings, and roads sometimes take the place of wetland habitats where animals live, which puts species at risk. They also change the way rainwater, lakes, and streams flow, and pavement and concrete block rainwater from refilling underground water supplies. There are more of us, and our demand for water at home, in industry, and in agriculture has grown tremendously. But all the water we have is all the water we will ever have. There is no more water now than there was 100 or even 1,000 or even 10,000 years ago. And there will be no more 100 years from now when the population may be closer to 10 billion people. We need to find a balance between our demands for water and the amount of water that's available to us. So here's showing you people going to the well. This one well, that's where we're getting all of our water. We need more and more water for crops and livestock in order to feed Earth's growing population. By 2025, many experts predict that 1 out of every 4 people will live in a country that is short of water. Guys, that's only in 4 years. By 2050, 4 billion people may be living without enough clean water. That's only a few more years away, right? If we're in 2021, how many more years is that? Every day, all the world's livestock, that's including cattle, sheep, pigs, goats, chickens, drink the equivalent of more than 160,000 large tanker trucks full of water. While dams make more water available, they also change the flow of river and they damage habitats. So we have to think about the other organisms that live in the rivers. Pollution in the well. The water cycle helps keep Earth's water clean. As water evaporates, minerals, chemicals, and dirt are left behind. The water vapor that rises into the atmosphere is relatively clean. When rain falls back to Earth, some of it is filtered through rocks and sand and is further cleaned. Even plants play a role. As water travels through them, plants remove chemicals in the water. Then they transpire clean water back into the air. But more and more waste from industry, agriculture, and homes is getting into the water. Runoff from backyards, city streets, and farms dumps dirt and chemicals, such as pesticides, fertilizers, and detergents into lakes and rivers, streams, and ponds. Pollution in the atmosphere from cars and factories mixes with the water vapor in the air. The rain that falls pollutes surface water and groundwater. Our actions may be overloading water's natural ability to clean itself. As more water becomes polluted, there is less clean water available. Nearly 80% of all sicknesses in the world are caused by unsafe water. And wildlife suffers too. Water pollution threatens the health of many species and habitats across the planet. Because of water's self-cleaning powers, the effects of pollution can be stopped and quite possibly reversed. But to do so, we need to reduce the amount of pollution that gets into the water. Water dissolves more things than any other liquid, so in nature, water is never really pure. It almost always has something dissolved in it. Every day, 1.8 million tons, 2 million tons of garbage are dumped into Earth's water, enough to fill more than 15,000 boxcars. When pollution in the air mixes with rain, it can turn into acid rain or even acid snow. This acid precipitation can fall thousands of kilometers or miles from the source of pollution, even reaching remote areas such as the Arctic. Wetlands are nature's water treatment plants. They absorb chemicals and filter out pollution and waste. Saving the water in the well. Water has the power to change everything. A single splash can sprout a seed, quench a thirst, provide a habitat, generate energy, and sustain life. It also has the power to unite or divide the world. Water is the most basic and important need of all life on Earth. But Earth's one well is in trouble. There is simply not enough clean water to go around. Taking action to conserve water can help save the well. Conserving water means protecting both the quantity and the quality of water on Earth. For example, using less water helps prevent water sources from drying up, and reducing water pollution protects the overall health of the well. Water conservation can help ensure that there is enough clean water for everyone on the planet. By becoming more aware of how you use water and by using less, you too can protect the Earth the water in Earth's one well. Remember, every drop counts. Here we see a passage. It's called Becoming Well Aware. And so they give us a few more facts here of things that we can do to protect our water and conserve our water. There's notes to parents, guardians, and teachers to give us ideas of different things that we could discuss and talk about. And here's our index. So if I asked you to go back and look up a topic, say for instance photosynthesis about plants, you would be able to do that easily. All right, I hope you enjoyed this story.